Hi, my name is Nando Mogollon, and this video is essentially inspired by a post on LinkedIn by Kevin Thicket from Oricon, where he was essentially expressing his frustration over having to go through a series of, I think it was about 500 issues, sort of to validate both services going through beams and particularly the presence of holes in those beams or penetrations in the beams when these penetrations were not aligned with the services. Essentially, trying to find whether either a service like so needed to be moved or the pipe needed to be moved. So in those cases, he had to go through one by one, and essentially was taking quite a lot of time. So I thought of that, and I decided to come up with this video just to show an alternative that may be able to save time on that by using rules and rule sets in Solibri Office. So what I have in here is nothing but a mock-up of the same situation or similar situation, where I have a structural file and a services file just with a few pipes, but I've tried to make sure that I have a few different situations here. So I have situations where, like this, where the pipes are running through the penetrations and holes on the beam, so no problem should be found. We also have the complete opposite, so full clashing, which should be ignored because they're far too easy to be picked up. And then I have three other situations, namely up here in the first beam, then this mid one, and then the last one, where I actually have beams with penetrations, but the pipes running through them are not quite cleaning up the hole. So they have a clash in here, although the penetration exists, but it's nearby. Same thing in here, where I have the penetration, but the pipe is far away. And a slightly less evident one where I have the pipe running through the penetration, but it might be too close to the edge, not centered, or just simply clashing in one of the sides. Not completely, but that's just slightly. So in order to get to that, what I've done in here, without going into much detail, is a series of rules that I've created for this particular challenge, if we can call it that way. I have more than I actually need. At the end, I probably just need these two that I have in here. But I've created all the other three sort of to prove the concept and the logic that Kevin was following. And it was described as it follows. First, you check if the beams have holes provided. So essentially checking that beams have the penetrations. Then checking if there is a service going through the hole. In which case you have two different resolutions. Either there is a service running through that, which then will tell me, all right, there's no problem there. But for the ones that do not have a service to them, then what do we need to do? Do we need to move the hole, or do we need to move the service? In that case, I believe there's still the need for human intervention, because only a person can tell whether you need to move one or the other depending on the context and situation. But it needs to be said that you don't need to go over every single one just to decide that. You just need to focus on the cases where you have those penetrations and you have a pipe clashing or a pipe that is somewhere nearby the particular hole. So those are the situations where I need to focus on. And that's the logic that follows the sequence of, is the hole being provided? Is the service in the hole? If not, does the hole need to move? If the hole doesn't move, do we need to move the service? So following that logic, I've created these rules in here. The rules are as follow. The first one is a very simple, actually I need to run this quickly. There you go. The rule that I have at the beginning is just to prove the concept, although it might not even be necessary to go any further, but this one doesn't really follow the same logic, but it does at the end provides the same effect. What this is doing is clashing beams and services, but it's dividing the clashes in two, as you can tell there. And I'm dividing them in a way that I can then go and ignore the hard clashes like this, where I have just pipes running through a beam with absolutely no penetrations. And I can say, yeah, that being one issue can be ignored because those are too easy to be picked up and probably don't have them anymore. And I will focus on these other three instead, which are pipes that do have penetrations, but the service is not really going through it and not cleaning the actual penetration or hole. So those are the ones that I need to focus on. So I could be doing that in that way, but I'm not 100% sure if I got the full picture. So instead, what I've decided to do is follow exactly what Kevin described as to be his logic. So what I've got in here is every one of those steps. So in here, I'm checking if the holes have been provided, in which case is actually filtering out, as you can tell there, where are the pipes, and those are going to be these three. Filter out pipes that do not have openings in them so that I can focus only in those cases. Then after doing that, or together with that, then I need to find, let's start with the situation where there is a hole in the beam and there's also a service in it. So if the service is in this hole, I still may be able to and should check any situations where the pipe is either too close or slightly clashing with the edge of the opening, which is this particular case. So it's not being asked, it's not evident that the issue that or challenge that Kevin was proposing will look for that, but that is something that might be interesting for someone to follow. See if the location of the clash requires some sort of modification. In this case, I will say, given that, I may want to move the opening just to match the rest of the openings along the root of the pipe. So that's that. Then if I focus on the actual logic, then I need to find holes without services. So services that do not have any holes around them. And those are going to be these two, sorry, the other way around, beams that do not have a service running through those holes. So there's going to be that and that, and I can see them being highlighted here and there. So if I can find them, then I can question and run the next rule, question the model for any pipes or services that could be nearby those penetrations or holes that are not being used. And for that, I can run this rule in here that is actually effectively finding those components. So I have one here, and that essentially is telling me, look, I have this opening and I actually have two pipes around them, so one of them needs to move. This one obviously doesn't have to move, but this one does. This one is actually controlled by a proximity of, I think it's 500 millimeters or so, but I can control all of that. I can make it whatever I want. And the second one, the one at the bottom, that is essentially saying, and this one here, sorry, that one there, it's a hole, but the next pipe around, it's here and it's already have a hole, so it's going to be up to me to go and find the pipe that needs to be moved. I will say this will be a case in which this pipe needs to move, or actually, not the other way around, the opening needs to move and match the pipe position just to avoid a deviation there. But the point in here will be that I can easily, based on these rules, and what these rules are doing is we call these gatekeepers. These are essentially, in logical terms, there will be if conditions. So if there is a service in the hole, go and check where the services are slightly clashing, like so. In this case will be if the service is not in the hole. So whenever you have empty openings or empty holes, then go find any services that are around those holes. Therefore, rather than focusing on 500 of them, you just can focus on the ones, on the particular situations when you have openings that do not have services running through them. All right. I hope, Kevin, you find this useful and interesting, and I hope it's interesting for everyone else. Thanks for watching.